So today I will solve the problem of the day of Leetcode named as maximum number of events that can be attended. So you have been given an array of events. So we are having some number of events and which is represented as start day I, end day I and value. What is the value? Suppose if you attain the event I, then you will get a value I from that event. Okay, and you can't you can't attain greater than k events. That what it has been said here, that you also get integer k which represent the maximum number of events you can attain. So you can only attain only one event at a time. You can choose to attain, if you choose to attain an event, that you must attain the entire event. So you can't left the event in between. And note that the end day is inclusive. Okay, so suppose if an event ends at day 2, then you can't then this can't happen that the second event will you will start from the day 2 itself. No, you can attain after day 2, that is uh, at day 3 or day 4 and so on. Okay, so now you have to return the maximum day of values, maximum sum of values that you can receive by attending events. Okay, so now how to proceed with this solution? How to proceed with the solution? Okay, first of all, let's discuss the test cases examples. Okay, we have been given the first event as 1 comma 2 comma 4, means it will start as 1 and at 2, and the value which I get will be 4. And if for event 2, the it is start at 3 and at 4, and the value I gain would be 3. And the third event start at 2, 3 and 1. So here is the solution, that you should attend only the first event and the second event, because if you attend the first event, then you won't be able to attend the event 2 comma 3 comma 1. Okay, but you will be able to attend this. So you will be able to attend only this 2 for the maximum answer. Okay, now suppose if the example is like this, then it will be optimal to attend only this, because if you attend this, you will not be able to either attend the event 0 or either event 1. Okay, so answer would be 10 here. And you can obviously see here that we can attend all the 4, but there is a constraint that we can't attend greater than 3 events. So answer would be 9. 2 plus 3 plus 4, so it would be 9. And let's talk about the constraint, that it has been stated that k into events dot length is less than or equal to 10 to the power 6, is less than or equal to 10 to the power 6. And start day or end day is less than or equal to 10 to the power 9, and value is of course less than or equal to 10 to the power 6. Okay, so how to proceed with the solution? One thing, to how to know that which is the next available event which I can attend after attending an event. Obviously I would have to sort to determine this, because suppose if the events are at random like this, then how will you be able to say whether I can attend this event after this event? Obviously not. But if I sort this according to the starting time, I will be able to support you. Suppose you are at this suppose you attend this event, then you can see which another event you can attend if it is sorted according to the starting time. Okay, and how I can do this optimally, by using the binary search. Suppose this is the ending, so I will just uh, do the binary search with the starting time of the events, and whichever is the minimum index which is greater than event ending of this event which I am attending till now, which I am attending now. So that would be the next available event I can attend. Okay, so now I will go to the solution itself. What I will do is that here by reading the question you can not say what will be the answer, because at each event you can't actually say by surety that if I attend this then I will get the maximum. So you will be having two options, either to attend an option, either to attend this event or not to attend this event. Okay, so okay, so obviously this is an indication of DP, DP with choice. Okay, because we are having two choices at each event, so either to attend that event or not to attend that event. Okay, and we have to find the maximum value. Okay, so yeah, why I was talking about the binary search and sorting and all, I can say I can say if I am able to say whether this event is available after attending this event or not. If I know the ending of this, if I store the ending of this event, then only I will be able to say whether this is uh, available or not, because I will compare the starting with the ending of the current event which I am attending. Okay, then only I will be able. That's why I am sorting. No, that's why I am sorting, so that I will be able to say whether I can attend this event or not while I am attending this, because I will just do the binary search with the ending day of this event, and will say if it is greater than, if the starting day of this event is greater than the event which I am attending or not. Okay, so let's code it. I will explain it with the solution while coding. And with the number of the events. Okay, and I will create a solve function that will start from the end. So what actually the dpij, what actually the dpij, what actually the dpi will, it denotes that if we are at event I and we have attended, and we can attend at max k, event from now onwards, then what will be the answer, what will be the maximum value. Okay, now I will pass the events, but before this I will sort, since it start with the starting day itself, so it will be sorted according to that only. Events dot begin, events dot end. Now I have k. Okay, and solve of int I. Suppose I am currently at index I, means I am deciding whether to attend this ith event or not. Okay, and n is the number of the total events. Vector of vector events, and then k. Suppose if I is greater than equals to n or k is less than equals to 0, does it make sense to proceed further? If I is less than equals, if I is greater than equals to n means I have gone through all the events. It doesn't matter whether I have decided that event or not. So what would be the answer? In that case, obviously return 0, because I can't gain any further value by attending events. Okay, or if I have attended all the key events, then also I will return 0. Okay, otherwise I will be having two options. That's why I will say answer is equals to maximum of. First option is what? If I attend this, events of, then I will get events of I plus 2, because the value is stored at the index 2 of a particular event. Okay, and I will go further, n comma events comma k minus 1. Why k minus 1? Because I am attending one, since I am utilizing one uh, event, so obviously it would decrease by minus 1. Okay, answer, and second option is what? Answer is equals to maximum of, I will just skip this event, and uh, just carefully observe that I have not decremented ky, because I have not attended this event, and now I will return the maximum of both. But one thing you should observe, I will do I plus 1 here, but it is optimal. Is it optimal to go to I plus 1? Because if I go to every indices, means I will check every indices, then it is not optimal. It will be it will result in time limit exceed. It will result in time limit exceed, and it's not optimal. Means I can say that it's not optimal. Means I have, that's why I sorted the events so that I am able to say which is the next available. So suppose if this was the event which was next available after this event, then why I would check the events in between them? It's not optimal. That's why I would to reduce the time complexity, I will use binary search. Okay, in next next available Okay, I will pass the current index I am at present, and I will also pass the sorted events, and I will pass and n. Okay, now in what can be the low answer? I plus 1, obviously I will check for the next, just consecutive next. And what can be the maximum? N minus 1. And suppose if nothing has been passed, if nothing has been if now no available events has been found after this, which can be made available after this events. So obviously our answer would be n, because if I pass index n, then I would encounter this situation. Here it will be not I will just pass index, and I will first of let's name it next. So I will just go to the next index. Next is equals to next available. Next available I comma events events, and then n. Okay, and I will pass this. This will bring me the next available event index. Okay, and now I will perform the binary search. Low is less than equals to high, mid is equals to low plus high minus low by 2. If if events of I comma 0, not I, it should be mid. Means if it is starting, means the index which we are going to check is mid, and if that if the starting day of that event is greater than the ending events of I comma 1, then obviously I would be able to go to that. So this can be my answer. As of now, this can my answer, but I will check if there exists an event which is between the ith and the mid, which also satisfies this condition, because I want the smallest. Why smallest? So that I can I can further check for getting maximum values, as my goal is to get maximum value. Okay, so I will check at mid minus 1 also. I have stored this answer, but I will check this before also. Else low is equals to mid plus 1. And finally I will return the index. Now, I just first of all run it, then I will memorize. Yeah, it's giving the correct answer, so let's just memorize. You can memorize it by map also, or DP also, because you are not sure about the event's length. You are not sure about the event's length. It can be possible that although both will pass, because it is both the products is less than equal to 10 power 6. So let's memorize with the vector itself. I will initialize every increase in the DP with -1. Always initialize the DP with the values which can't be possible in anyhow. Okay. K plus 1, just for the sake of safety. If dpik if dpik is not equals to -1, return dpik. Means I have, if I have already computed that answer, so that's not there doesn't exist a point to just to compute again and again. Okay, let's run it. Yeah, it is giving correct answer. Let's submit it. Yeah, it got accepted. So talking about the time and space complexity, what would be the time complexity here? I am checking at each index, and I am using n log n, n log n. So it would be n into this index. I will run for n time, and I am running the binary search, which will take log n. So it would be a solution of n log n. Okay, and what would be the space complexity? Obviously, it is n into k. So yeah, that's all about this question. Thank you.